Okay, today we're going to continue our discussion on navigating through R and R Studio. So let's open an R file. Let's open our R. And what's one of the most important thing that we have to learn as far as managing or organizing our files in R is to learn how to create a project. Now, projects are very important because it helps us organize. It helps us organize our files. So if you have your RMD, how do you create a project? So to create a project, you go here, File, and then we're not going to open yet a new file, but a new project. What's the purpose of a project? A project is supposed to help us organize the files that we're working on. So you might have different R Markdown files, and it's best to organize them into a particular project, especially if those Markdown files are related. So how do you do that? So under File, you click New Project, and then you'll be brought to this option where you either open a new directory, or you open an existing directory, or a version control. So for our purposes, let's open a new directory. Okay, and then here you are asked if are you opening a new project, are you going to open up R package, a Shiny application for website, Quarto project, Quarto website. Later on, you'll be required to open a Quarto project instead of an R project. But we learn first R project because it's easy to migrate from R project to Quarto project. Okay, so here you have a new R project, new project, and let's click this. So let's create a directory name. Let's suppose here we have, let's see, this is data. We're going to learn data wrangling. So this is our project. We call it data wrangling, which means navigating through our data. And then where do you want to create it? Create project as a subdirectory of, let's browse. Okay, I'll put it under desktop. Okay, and I'm going to create a new folder here. Okay, new, and I'm going to create, I'll call it R, let me see, R projects, FINTSAR K32. Okay, let me name it FINTSAR K32. Okay, and then, so the folder is now saved here, and then open. Okay, so the directory name is data wrangling. It will be under in my C, okay, my drive C, and then desktop, and then under the folder R projects FINTSAR K32, and then I'm going to create now a project. You can click this, open a new session, okay, but I'll just create a project. Okay, so what happens now? Okay, now I have a new environment here. Okay, the environment is called data wrangling. It's here. Okay, and then you can see here the project data wrangling. If I click this, you can open a new project under this project. Okay, new project. Okay, so you can do some things here. Okay, all right. So we now created a project called data wrangling. Okay, so let me, and you can see here that under files, you have this one, data wrangling.r project. So this is what R created. So this is a documentation of the object that we're creating, the R project that we're creating. Okay, let me pause for a while and give you time to do that yourself. And if you're done, kindly chat, please, that you're okay, that you have done it. If you have any questions, please feel free to Ask questions now. If you're done, kindly chat yes, please, so that I know you have already created your project. So what's good about this is that if you are in this environment, all the files, data files, output files will be saved in your project. So it makes life easier because you are identified in this project, and any file that you're working on in this environment will be saved automatically to that specific project, to that directory. Okay, how about the others? I'm only seeing five out of 20. That's not a good participation rate. A few more seconds and then I continue. So that's only a 65% participation rate. How about the others? I hope we can even reach up to 80%, at least 80% participation rate. Okay. All right. One of the things that we need to check is where is our environment? Where is the working directory now? If we write get wd, okay, this means get the working directory. So we are working in this environment. Let's see what's the working directory that we're with now. Okay. So you can see this that our working directory is in my case it's I saved it in C. Okay, and then in the desktop, then I created this folder RProjects FINTSAR K32, and under that is this project data wrangling. Okay, then you should also get the same wherever you saved your project. Okay, so that's good. Clear so far? All right, then let's create now our markdown. So let's open a script. Let's open an R markdown. So there, and let's name this data wrangling session 1. Okay, data wrangling session 1. Okay, document. Okay, we can use no. Let's use the date today. Okay. All right. So this is now our file. Okay, this is now our RMD file. Okay, let me first close this outline and let me delete this so that we can work on our new RMD file. Okay. Right. So today we're going to discuss, before we go into the formal linear model, the regression model, let's just learn how to let's just learn how to prepare our data. Because usually when we get data either from the internet or from the other sources, it's usually not ready for any data statistical analysis. So we have to learn how to wrangle our data, which we call data wrangling, or cleaning your data or preparing your data so that you can perform statistical analysis on that. Okay, and the package that we're going to use is one of the package that's very helpful as far as cleaning or preparing your data is a dplyr. However, Okay, uh, let's see, packages. Let's call it. What are the packages that we are going to use? Control Alt I, and since we have installed tidyverse before. Okay, let's just load tidyverse. If you recall, we already installed this package before. If you have not, please install this first by writing installed packages. Okay, and then here, let's give this a name. A good practice always is to put here packages. Then there's another package that we're going to load later. Okay, and that's DS Labs, but most probably library DS Labs. Okay, so most probably you haven't loaded this. So may I request you to just write it in your console here, install the packages. And then you have here a DS Data Science Laboratory, DS Labs. Okay, and after you have loaded, install this package, and we'll run this. Okay, so let me run this now. For the rest of you, kindly install DS Labs first, and then once you're done with it, we will now load tidyverse, and you will see that tidyverse is actually consists of several packages with it. So you notice that tidyverse consists of the ggplot2 package, the table package, tidyr, readr, per, okay, dplyr, stringr, and forecasts. Okay, so these packages have already been loaded, and then let me load also DS Labs. It's still loading. Let me see here. One or more packages to be updated are currently loaded. Restarting. Okay, let me restart R. Okay. All right. So there, package DS Lab successfully unpacked and loaded. Okay. So I'll wait for your Go signal class if you're okay. If you have loaded both tidyverse and DS Labs. Kindly chat, please, if you're okay. If you have downloaded loaded those packages. Okay, thank you. Thank you for your feedback. Let's wait for the others to give their feedback, please. A few more seconds. All right. So let's see. Okay. So first, let's have a brief review of what we have learned so far as far as data structure are concerned. We learned that the most important data structure for us are either data frames or tables. So let's load some data sets. Okay. By the way, let's take a look at this package, DS Labs, just to familiarize ourselves with this particular package because we haven't used this before. So let me use the console here. Okay, since notice it's not running with single question mark because it's a package. So oftentimes if it's a package and you have to use double question mark there. Okay, so here you have, all right, DS Labs. Okay, maybe I should use the help function or the package function and write here DS Labs. Okay, notice that DS Labs, I already installed it a while ago. Why is it not yet? It's supposed to be checked here. Okay, checking the package in the packages section is equivalent to writing library. I'm not sure if, did I, oh, sorry. Yeah, I installed it, but I have not loaded it. Okay, so there. Had I loaded it, typing library, then when I go to the packages section, I would have seen this. It should have already been checked. Okay, so let me see what's inside here. Okay, so here, description file. So the DS Labs Data Science Labs package, this contains data sets and functions that can be used for data analysis practice, okay, homework and projects in data science courses and workshops. There are 26 data sets available for case studies in data visualization, statistical inference, etc. Okay, so let me go back to, let's see what's contained here. So there are 26 data sets here, and we're going to look at this one, the murders data set. Okay, so let's type here data and then murders. There, it will now, Excel has IntelliSense, and it's now available since we already loaded this particular package. Murders, then Control Enter, then it's now available here. Okay, and if I type view murders, okay, it will generate a spreadsheet. So what are the elements here? There are 51 observations, 5 variables, state, abbreviation of the state, the region, then population, and then total. So the first question that comes to our mind is, what type of data structure is this? Okay, what type of data structure, anyone? What's a data structure? And somebody answered that. Yes, sorry?
Data frame.
Yes, correct. That's correct. That's a data frame. We can check the structure. Okay, we can write structure and then murders and try to see what. Okay, so it's a data frame. Data frame with 51 observations. And then you have the variables here, $state, which is character, $abbreviation, which is character also, $region, which is a factor with 4 levels, population, numeric, and total crime rate. Okay, total murders. Let's open this and see what the metadata is about. So the details are the state, the abbreviation, the region, the population, and total here refers to the number of gun murders in the state in 2010. So this data, this is actual data. It's from, the source is from Wikipedia. Okay. Gun violence in the United States by states. Okay, so it's just the 2010 data. Okay, let me just close that. Okay, so back here. Are there any questions? Frame, thank you. Yes, thank you, Carlos. Carlos, please share your question, your answer to everyone. Okay, so you have seen how I navigated through our studio, and we have seen that indeed this is a data frame. These are the variables. We can actually also summarize this, what we have learned so far. Summary of murders will give us some information about the data frame. Okay, and then we see that the state is character, just gives us the length, the count, also the abbreviation. The region is a factor, so it will give us a distribution of the different factors, northeast, south, north, central, west, and the count, the frequency. And then population is, the maximum is 37 million, right? And the minimum is 563. So there are states that are really densely populated, and there's states that's not even 1 million. Okay, and there's this zeroth quartile, first quartile, second quartile, third quartile, fourth quartile, and the mean. Same thing with the total murders in 2010. Okay, so this is a data frame. Okay, so now it's important to know why is this a data frame. If you recall, we said that a data frame has each rows pertain to a single observation. Each row has a name. In this case, the name is the index. It's 1 up to 51. Each column also is unique in the sense that each one has its name. Okay, so this is a data frame by virtue of those attributes or characteristics that pertain to a data frame. All right. Now, as a practice, let's take a look at other. Let's put here data sets. It's always good to give names to code chunks. Okay, let's take a look at other data sets. So, for example, there's a package. There's a data set in R called CO2. Okay, let's run this. All right. CO2. And if you view this, view, CO2. Okay, we have an IntelliSense here. Okay, what type of data is CO2? What data structure? Anyone, please? What is the data structure of CO2? It's you can see immediately here, class. It's an environment. You'll know that.
Times.
Sorry?
Oh, sir.
Sorry? You get choppy. What's your answer?
A timer.
Emil, I didn't get it. Sorry?
Time series, sir.
Time series. Okay, it's okay, time series. Pero anong structure niya? What data structure? It's actually a letter V class, letter V. It's a vector, di ba? It's a vector to eh. It's numeric vector. If you take a look at the values, yeah, it's a time series, pero ang data structure niya, vector siya, no? Vector siya containing data from 1959 to 1998. CO2, this might be carbon emissions, no? So we will not anymore look at the metadata, but that's an example. Okay, let's have another example. What about, let's get, okay, so here, there's this object from data sets, the chicken weight. So let's run this, data chick weight, and let's see. So let's view chick weight. Okay, we can see that. All right, you have the weight here, the time here, the chick, and the diet. Okay, what type of data is this? 578 entries or 4 columns. Anyone? You have weight, you have time, you have the chick, and then you have the diet used. So apparently this is chicken number 1, and you were taking, I don't know if these are months, from month 0 up to month 21, observation about the chick. Okay, and they were measuring the weight of the chick from 0, maybe 0 months up to 21 months. Okay, and the diet that was fed to the chicken, to the chick. Okay, so what type of data is this? If we get the structure of chick weight, you can see that this is all right, this is a group data, data frame. So it's a group data and a data frame, 570 observations. You have the weight here, okay, and then the time, and then you have the, this is, if you recall, this is a factor, ordinal factor, which means that there is order to the classification. And then, what else? The chick and the diet. Your diet is a factor. So 4 levels, 4 types of diet, 1, 2, 3, 4. The chick is ordinal, which means that it has a ranking. Okay? So any questions? Clear so far? Okay, other types. I think there's, maybe I showed this to you a while before already, the orange data set. So let's take a look at this. And let's view this, view orange. Okay. So 35 entries. Okay, let's see what data type is this. All right, just like the chick weight object, this is also a group data with how many variables? 3 variables, the tree, the age, and the circumference. Okay, so apparently we have here 35 divided by 7. That's the 3 is an ordinal factor, 5 levels, 1, 2, 3, 4, 5. Okay. All right, but it's still a data frame. However, a special type of data frame. It's a group data frame. So you can see here the grouping: 3, 1, 3, 2, 3, 3, 3, 4, and 3, 5. Five groupings. Okay. So there are so many so many data sets that we can use in R. We can use the datasets package. We check datasets. You can see here, and here, datasets. You can see here the different datasets. Okay, here, datasets. The R datasets package. And if we take a look at the description file, okay, the R datasets package, and how many? No information here. It does not tell us the number of datasets that come with it, but we can make use of this. We can make use of the dataset that comes with not only datasets package, but other packages. Okay, we learned before that ggplot2 also contains several datasets. Okay, so what's important is for us, when we see when we access a particular dataset, we should know what data structure that data is. Okay. All right. For our purposes, we're going to look at this dataset, data murders, since it's already existing here. Okay, murders. We're going to make use of that. So let's first take a look at our data murders. So there are 51 entries here. Okay, this is a data frame. Each row is its own observation. Okay, and then the columns have their variable names, and then each row has a name. It has an index here, 1 to 51. Okay, so this is data about the murders that occur in each of the states in 2010. Okay, maybe let's take a look at the total here and sort this out. So California has the highest number of murders in 2010, 1257. And it has a population of 37 million. Well, let's see, the lowest in terms of Vermont has only 2 with a population of 625,000. Okay, so data wrangling means that you you do something with the data, you manipulate the data so that we get what we want. Okay, for example, we want a particular variable that should be part of this, then we can make use of data wrangling in order to either add a new variable, remove a new variable, filter the rows, create a computation, etc. That's what we call by data wrangling. Okay, so it's also important first, before we do data wrangling here, to know how to save this. Okay, because this data set is in our environment murders. Okay, if I want to save this in our working directory, okay, how do we do that? How do we do that? Okay, let's seek the help, write.csv. Okay, so we have this function write.csv, and okay, if we click this, Control Enter, and what's the syntax of this? Okay, write.csv, write.table, write.csv. So if we take a look at this here, write.csv, okay, write.csv, and then, okay, take a look at this, write.csv, and then the file name, and then the file that you want to give the name that you want to give it to. Okay, so why don't we copy this? Control C, and then save, say save file or write file, not save file, write file. We want actually to save the file, the murders file. Okay, let's say save murders file. Okay, or write murders file. So write.csv, and then our x is the object. So x R will recognize that because we have this object, and then files. Let's call it murders. Okay, murders.csv. Okay. Now notice we're not writing anything anymore here. Actually, the complete one should be you should identify in which folder you would want to save this. Okay. All right. So let's try this. Write.csv and then murders file is equal to murders.csv, and let's try to see what happens. All right. What happened? If you take a look at files here, note. So you now have here in your directory, that's why, as I said, this is very important as far as working as our saving a directory is concerned. So any output that you generate will automatically be saved in your project directory. So you can now see here murders.csv, and if I open, let me see, I'll open the where did I save it? Here in our projects here, and this is my data wrangling our project, right? Okay, you can now see that I now have this one. Okay, the murders. This is a CSV file. So I was able to save that. But later on, if you need this, you can easily access it. Okay. Okay. Any questions, class? And same thing later on, if you want to upload that. Okay. So you just use read.csv, and then you can access that. Read that file. And you don't have to name the file location because you're working in your project. Okay, automatically, you know that the location of this project is in the project that you designated, which you designate. Okay, once again, let's see, get working directory. Let's just check. Okay, there you are. Okay, so we are in, I am in the desktop. So I created my folder there, our projects, FINTSAR K32, and then this project, data wrangling. Okay, so that's my working directory. All right. Any questions so far? No questions? Okay. So we're going to use this murders dataset, and let's do some wrangling out of that. Now, we can make use of the very powerful dplyr. Let's type this dplyr. Okay, this is a package, and here there are many. Let me use the package here. Type dplyr. Okay, so it's supposed to be loaded already. Kasi nag-library na ako eh. I don't know why it does not. Let me run this again. Library tidyverse. Okay, when I run library tidyverse, notice that dplyr checked itself, which means that this is already loaded, and I can now make use of the functionalities of dplyr. I don't know what happened, why it became unchecked when I already loaded the tidyverse. Anyway, so let me click this. Okay, so here are the functions that are available for dplyr. Okay, there are lots of functions that we can make use of here. And the first one that we're going to make use is the mutate function. So let's just look for that, mutate, this one. So mutate, Okay, so what does the mutate function do? It's coming from dplyr package. So the mutate function creates new columns that are functions of existing variables. So you have several variables in your data set. You can create a new column uh, using a function of the existing columns. For example, you have column 1, and then you would like to create the square root of that column 1. So you can do that. You create a new column, and then the formula is the square root of column 1. So that can be done using the mutate function. It can also modify, okay, and also it can delete columns by setting their value to none. Okay, so if you take a look at this sample, so mutate, okay, so this is the data, and then here you're saying what you want to keep, and then before, and then after, okay, but it's best for us to take a look at an example. Okay, so let's have this example, like Control Alt I, and we have this mutate, no? Mutate function. And maybe a good way to, okay, so I'm going to do here, the first, for practice, this is data wrangling using dplyr. So this is our topic. And then this one can be number 2, 2 hashtags, which means this is part of, I'm trying to create an outline out of that. Loading packages. And then you have here loading data sets, maybe another hashtag. And then here, let me just saving a file in RMD. Okay, and then another hashtag using mutate function. Okay, if you take a look at this now, at my outline, you can see here that this is my main outline, number 1, and then this is number 2. So where I'm now here, okay. So these are my outlines, and it's done by the hashtag here. Okay, if I create another one hashtag, then that would mean, for example, another main, take a look, plus. While I'm writing this, another main outline here. Okay. Okay, if I make here another 1, 2, 3, just to check the outline. 1, 2, 3 here. Third one, this should be under the second one here, right? Trial outline 3. And you notice here, it's under the second one, trial outline 3. Okay, so it's very easy to do outlining in R. Okay, so let's use the mutate function. How do you make use of the mutate function? The syntax is mutate, and then identify the file name, and then identify the file that the column or the variable that you want to create. Okay, so let's see. So we're going to create this object murders. Okay, alt minus, and then we're going to mutate. What are we going to mutate? We're going to mutate the murders, which means either we we are deleting a column or we are creating a new column. Okay, so we're creating a new column. Let's create a new column. Okay, let's just put this here. Create a rate column, which is equal to rate column is the per capita, which will be equal to the total deaths divided by the population, and let's make it per 1,000, 100,000. Okay, so let's create. We're going to create this a column called rate. So this is the it's like a per capita. So here we're going to write rate. This is the name of the new column that we're creating, and it's equal to total. Okay. The total, if you recall, the total is the number of deaths divided by the population. Okay, that's total divided by population. And then we multiply, since the total is a very small number, they divide by the population. Let's just multiply it by 100,000. Multiply that by 100,000 to make it number of deaths per 100,000. Okay, so let's see what happens to this one. So it's still the same object, murders. However, the use of mutate will mean that either we're creating a new object, a column, or deleting something. Here, we're creating a column called rate, and we're giving the formula. Okay, so let's run this. So let's see what happens. Okay, so nag-run siya, no? Dito, it's okay. Oops, sorry. Ano nangyari? Object on, I have, sorry, spelling is wrong. Population, okay? So if you encounter problems like this, be sure to check. Object population, which means that I had wrong spelling. Okay, so let me run this again. All right, so let me check the murders object. A while ago, it had 51 observations and 5 variables. Now, if I click this, you can now see that it now has a new column, new variable called rate. Okay. This is a new variable called rate. Okay, let's we can sort this. Can we have this one? The highest rating is in the District of Columbia, 16, and the lowest is it's in Vermont. No? So it's here. That was understandable because it had a very small gun murder, and then a small population. So there are only 0.3 gun murder rates per 100,000. So not even one. While here it's 16.45 in DC, Washington, DC. Okay? So that's how we create a variable, include a new variable in your object. Okay. Any questions so far? Any questions? Okay, thank you. How about the others? Okay. Now you notice here, mutate, murders, and then rate is equal to total. If you recall before, we can only access a particular variable in a object if we identify the name of the object. So here, why are we not writing murders? Okay, if I get the names of murders, names, murders. Okay, so these are the variable names, right? State, abbreviation, region, population, total, and now we have rate. Now, my question was, didn't we need to put here murders dollar total, murders dollar population? We didn't need to do that because we already identified what the object was, murders. Okay? And the mutate function allows us to do that. Just identify the object and then you can already use the variable names. All right. Any questions so far? Okay, I hope it's clear. Okay, next, let's use another function. Let's see, using filter. So what's the purpose of filter? To select. So filter is used to select specific rows based on the values of a variable. And the values of a variable are your columns, right? Okay, suppose let's okay, filter, print. Let's print the uh, the the subset of murders with rate, let's say rate greater than or equal to 2. Okay, so suppose I want now to just print the states whose rate is greater than or equal to 2. So I have here the murders data set. If I can sort this, and then you can see that those that have murders greater than 2 are Indiana up. Okay, or maybe let's, yeah, we can do that. So how do we do that? Okay, so if we just want to print, then we'll just type filter. Okay, filter, what do we filter? Okay, before we filter, okay, filter, so we have murders, and then rate is, okay, so we're going to filter murders where the rate is greater than or equal to 2. So let's run this. Okay, so here we have the rate, and all the rates here, you have 31 rows, which means 31 states. Second panel, third panel, fourth panel. So 31 rows all in all, 31 observations with the rate greater than 2. Okay, let's, or maybe we can make this lower, 3, so that we have lesser size. Run. So less, greater than or equal to 3, there are 19 rows. So this will print only those states with murder rates per 100,000 of greater than 3. Okay? All right, clear, class? Clear? Questions so far? Is this clear? Yeah, there's a good question here. Can it be organized by highest to lowest? Yes. Okay, so how do we, let me answer your answer after I answer this. But take note, class, take note that if I view murders, it still contains everything. Okay, still 51 entries. Okay, because we just printed this. We just printed those that have murder rates greater than 3 per 100,000. If I want an object, to, okay, let's see, create object with a rate greater than equal to 3. If I want to create that object, then we will have to say murders underscore greater than or equal to 3. Okay, let me just name it that way. Okay, so again, just make sure that you give names here always and make it a good practice. So murders, let me just put here greater than 3, greater than or equal to 3. So murders, and then what do we have here? How do we do this? So we start with murders. Let's copy this. Control C, then Control V, and then Control C, Control V. All right. If you combine this, will this create an object? Okay. Let's put this murders greater than or equal to 3. Okay. Okay. Here I'm creating an object called murders greater than or equal to 3. I mutated murders by creating this variable rate, and then I filter. Okay. So let's see. Will this create, if we run this full code chunk, will it create an object murders greater than or equal to 3? Class? Okay, please answer. Yes or no, please. Kindly chat, please. Yes. Yes ba? Yes. Yes. Okay. All right, let's see. I'm going to run this. Run this. Okay, and then let me see now this object murders greater than or equal to 3. Take note, it still has 51 observations and 6 variables. So it means it did not filter. 51 pa rin siya, di ba? And still the same, 51 entries, right? It still consists of the 51 states. Okay, what happened? So we were not able to create an object murders greater than or equal to 3 that has only the rate greater than or equal to 3. Why? Why did we fail to do that? Because first, we created this object murders greater than or equal to 3, and it just added this rate, and then after that, we just printed. This one is just printing the printing. In fact, even if we put here greater than or equal to 3, okay. So let's filter this object that we created, rate greater than or equal to 3. Again, let me run this. Okay, what happened? It printed 19 observations of states with murder rates greater than 3. However, the object murders greater than or equal to 3 has still 51 observations. So no object was created. It did not create that object. Okay? Now why didn't it not create? Because class, after creating this one, which still consists of 51 observations, we just printed it. Okay? So what could have been the best way to do this? Any suggestion? What would have been the correct way? If I want to create that object, murders that are greater than or equal to 3, what should I have done? Class. Any suggestion? Nabawasan na tayo ng participants. 15 na lang. Any suggestions, class? Suggestions, please. Can unmute yourself. Okay, use the mutate function, but replace rate with filter. Sorry, Carlos, I didn't get that.
Yeah, sorry, sir. I'm just guessing also.
Okay. Use
yeah,
the mutate
not
function, but replace the rate
with the filter. Or
How do you do that? Kasi you have to create this object rate, di ba? You have to create this variable. So ibig sabihin, wala na tayong rate. Rate is important because that will be the basis of the filter, di ba? Dapat yung rate greater than or equal to 3. Okay, but thanks, Carlos, for your suggestion. How about Jarod? Could you unmute yourself? What are you saying here? Jarod?
Hello, sir.
Yes.
Yun sa the murders greater than equal to 3, just move the, instead of mutate, just use the filter instead.
Filter. So instead of mutate, no? We'll use
Yes.
filter. Pero, okay, let's try that, no? Very good suggestion. Let's see, filter. Okay, take a look at this. Sabi ni Jarod, i-filter na lang natin, no? So ito pa rin, filter natin. Let's see. Okay, error in filter. Okay. Bakit? Bakit error to? Kasi hindi niya na-recognize kung ano yung rate. Diba? Wala namang object na rate. In order for us to create this, kailangan natin immutate to. Okay? Kailangan natin yung object na, yung variable na rate. Thank you, Jarod. That's a very good suggestion. But we have to create rate first. So we have to do mutate. Okay, so mutate yung murders. Okay, so what we can do is, okay, pwede rin namang, pwede rin namang still murders here. Diba? Murders. So yung murders natin, magkakaroon ng rate dito, diba? Which we actually have done. Okay? We have done this, no? Nag-mutate na tayo, existing na yan. So dapat yung ano natin, ito ba yung sinasabi mo, Jarod? Is this what you were saying? Murders, GE3, no?
Yes, sir. Then,
okay.
yun sa loob, sir, it's just murders. Walang murders underscore GE3.
Okay, sige. That's another way, no? That's another way. Or we could have created murders a while ago and then create another murders, but this time, if you filter natin, tatanggalin na natin yung more than, less than 3. So this is also possible. This is correct. Okay, so what are we doing here? We're creating this object, murders GE3. Okay, by the way, class, there's a comment. Okay, this code chunk will not create an object murders GE3 with rate greater than 3. This one, we create murders GE3, and then we filter murders. Okay, now murders, we have already created this. It has 6 variables, right? Including the rate. And then we filter only those that are greater than or equal to 3. So let's run this. Okay, and we now see that murders GE3 has only 19 observations and 6 variables. Okay, now another way to do this is, and this is the best way to do this, is introduce what we call the pipe operator. So this is how a pipe operator looks like. Okay, or another way to write a pipe operator is the pipe, and then greater than. Okay, let me explain what a pipe operator is. All right, so let me start with getting murders again. So here, data murders. Okay, so now murders will just have 5 variables. Okay, so it superseded the murders that we created with 6 variables. Okay, so we now have only 5 variables. It deleted the rate. Okay, so from there, what will happen is that I'm going to create murders GE3. Okay, we have the assignment operator. Then we start with murders. And then what happens? And we use the pipe operator. The pipe operator means and then. Okay, so first we start with murders. And then what do? We mutate. What are we going to mutate? We're going to mutate the object before the pipe operator, which is murders. So what do we mutate? Okay, and well, actually, we don't need to write the murders. The ordinary syntax of mutate is you write the name. Okay, but since you were using the pipe operator, it means that you start with murders and then you mutate. How do you mutate? We create this object called rate, which is equal to total, right, divided by population. Okay, population, multiplied that by 100,000 to make it rate per 100,000. Okay. So after this point, there's now a new variable, rate, right? Correct? Okay, are you following, class? From murders, we're creating this object called murders, GE3. We start with murders, and then we mutate murders. We add this rate, and then what do we do? What do we do next? Okay, another pipe operator. As I said, this one, the pipe operator means, it means and then. Okay, this one means and then. Okay? Parang sa Tagalog, pagkatapos, no? So we're creating this object, murders GE3. So we start with the murders dataset, and then we mutate it. No? Mutate it by including a variable called rate, which is total divided by population times 1,000. And then after that, what do we do? And then, okay, we filter, diba? We filter. What do we filter? What do we filter? We filter where the rate should be greater than or equal to filter greater than or equal to 3. Okay. And then, okay, let's print murders, although this is not needed because it will automatically print. Okay, take a look at this. Okay, so what are we doing here? First, we want to create this object murders GE3. So where do we start? We start with murders. Take note, murders is a data frame consisting of 5 variables. And then what do we do? And then we mutate. What will mutate do? It will create this object with this variable rate, which is total population. In fact, if we run this, what will happen is that we will have an object with 51, okay? Take note, Di ba? Yung murders, GE3, 51 observations. Okay, but after that, we filter, okay, rate is 3, and then we print. Remember, how do we print an object? We just write the name of the object. Okay, or type print murders GE3. All right, let's see this. Let's run the whole code chunk. Run. Asan na yan? Sorry, here. Okay. Errors, could not find the function murders. Wait. Ito, no? Dapat pwede ito. Murders, GE3, dala. Palitan ko to, ha? Maybe it caused confusion. Let me just run this. And then kasi dapat tama. And then dapat kasi function siya, no? Nalolok to mouse ko. Yan. Okay. And bakit siya nag-print ng maraming murders? Okay. There you go. Di ba nag-print siya, no? Print niya dito. I can just remove this. Let's see what happens if I don't print it. Okay, I think it will automatically print. Okay, so let me just murders 5 observations, ano? Okay, let me just run this line. Kasi yung murders ko dito existing pa 5 observations, 5 variables. And then control enter. All right, so let me check. Hindi siya nag-print, pero if you take a look at this, murders GE 19 observations, 6 variables, tama siya. Okay, so we were able to, okay, here, 19 observations lang, lahat ng rate greater than 3. We were able to generate this object, murders greater than 3, just with this one code chunk. Tapos hindi na tayo nag several layers ng code. Okay, because of this pipe operator. Okay, so the shortcut for the pipe operator is, okay, for Windows, it's Control plus Shift, okay, plus M. For Mac, it's Command plus Shift, I think, no? Plus M. Command Shift M. Okay. So let me replace this. Control Shift M. Okay. I replace this with Control Shift M. Okay. So I have here the two. I have here the two. Ano ito? Pipe operator. Okay, questions, class? Are you getting this?
Yes, sir.
You got the pipe operator? The pipe and then greater than?
Yes, sir.
Sure kayo pareho sa tayo ng pipe operator? Sure kayo, class? Pipe and then greater than sa inyo? Hello, class. Okay, no questions? Again, no questions. Ito ito yung pipe operator nyo Sige. Okay, so it's already time, class. Ano yung pipe operator nyo? Ito o ito? yung percentage greater than percentage. Yung sinasabi ko guys pareho ba tayo? Hindi naman kayo sumasagot. Okay? Magkaiba naman pala tayong klase. Ang pipe operator ko ito, yung sa inyo percentage greater than percentage. Kulang tayo ng questions class. Kulang. Let me stop recording already. Hindi tayo magkapareho class.